Welcome back to our Academy courses on Introduction to Open Source Security. My name is Ron. I'm part of the Endor Labs team here, and we've talked about open source security and compliance and licensing and and how you get visibility into your dependency graph. And now it's time to talk about the operations piece of open source reliance. So if you're using a lot of open source software and you have these processes and systems set up for the security and compliance and visibility even into open source usage, now you get to the ops part of DevSecOps. When we talk about operations for the purposes of this video, we're going to split this down into three main sections: outdated dependencies, unmaintained dependencies, and the impact of upgrades. There are definitely other things that you could lump into your operations, but we've covered a lot of those things like licensing, for example, in some of our other videos. So these are going to be the main three that we're going to focus on here. So let's start by talking about outdated dependencies. So the example here is you have selected open source software to bring into your code base to rely on for some specific function instead of writing it yourself, the regular use case for open source software. And all of these software packages have to be updated on a regular cadence to get the latest security fixes, to get the latest features, whatever it is. But for some reason, if you fell behind on these versions, you have now outdated dependencies in your code base, meaning old software packages that are multiple versions behind, but they are still receiving those updates. And the larger that gap is between the version of your software package and the latest one that maybe has either a security fix or a feature that you need, the bigger the technical debt that you're creating, the harder it will be to actually make that leap because of backwards compatibility issues, because all sorts of things that could go wrong and potentially break downstream relationships that dependency has with other dependencies. That goes back to one of our earlier videos where we talked about visibility into the dependency graph. So this is an old software package. It's multiple versions behind. You're still using it, but you have not updated it for a variety of reasons. It is still receiving updates, but those have not been implemented in your environment. It becomes harder to patch the older this package might be. So we need to put systems in place to update these packages regularly, and also try to decide when does a dependency become too old for the risk tolerance of my organization. So this is a good thing to have some sort of policy around of this is the biggest gap that I'm willing to tolerate. This is another area where it also becomes very beneficial to have some sort of visibility into your dependency graph, because then you are also able to prioritize, okay, this version is versions behind, this package is versions behind, but I'm actually not using this in production, or it's unreachable or anything like that. The same type of mindset that comes into prioritization for vulnerabilities could apply here as well. And we can take a look at an example here. And this is taken from the Endor Labs product, but the same can be achieved in other ways as well, where we have an outdated dependency here. We can see that this dependency is 54 months old and 75 releases behind the latest release. And now we have to make a decision of, are we going to go through the work of trying to update this, or will this be too much hassle? In this specific case, I can also see that this is an unreachable transitive dependency. So maybe there are other things that I can do here to work around here. But the first bucket of this operational risk that we need to understand and talk about, these are outdated dependencies. And of course, the fix for this is to have a regular cadence of updating the dependencies that you are consistently relying on. If we go to the next bucket, these are our unmaintained dependencies. So when it comes to open source, we of course are standing on the shoulders of giants. We are relying on other maintainers who are out there thanklessly maintaining the software that we use every day. And there are certain cases where, for whatever life reason that happens for these maintainers, they abandon the project. And this can happen for multiple reasons, and I'll go into an example in just a minute. But let's say that you are relying on a piece of software that is being thanklessly maintained by one random guy somewhere in the US, in Russia, wherever it might be. And for whatever reason, they walk away from that project. And now this project will no longer get any updates or security fixes, but it is core to your code base. You now basically have two choices. You either take support for it yourself, which means you make a fork of it and you basically create your own version of this product that you now maintain. Or if there's a vendor option available, maybe you bring in a vendor and you have them manage it. So you go into more of a commercial engagement around this capability. And the other option is to replace it with something similar. And of course, this is the reason why one of the most popular Google searches is alternatives for Log4j. What can I use in order to replace that package that I was relying on? This is, of course, one more area where visibility into the open source usage and status across your code base is absolutely critical, because you need to be able to audit and catch these things. So it's a good idea to, in quarterly intervals or whatever intervals make sense for your organization, always go back and take a look at the core, most important open source packages that we're using and evaluate them. Are we happy with their popularity and quality? Are people contributing to them? Are they active? Are they mature? Do they have CI? It is then also best practice to take all of these things that are now part of my risk profile and implement them as part of my selection criteria. When I'm picking new open source packages to come in, you're basically looking for these indicators for things that will most likely will not go unmaintained. And we can take a look at some examples for this. So this, for example, is an unmaintained dependency. And we know that because this repository has been archived on GitHub, which means that it will no longer be getting any updates. And now we have to decide, do we want to take ownership of this and somehow replace this functionality? Do we want to look for a different package? Do we want to bring in a vendor? This should be a trigger for a conversation about this. And again, prioritization can help here to understand, am I actually using this dependency? There's an interesting example of an unmaintained dependency with Core.js. Core.js is something that has been used by the top 1,000 websites on the internet. It had over 9 billion downloads. It was a huge package. This is a fascinating read. If you haven't, I suggest you look this up on GitHub and you read this, basically this article, this manifesto that the maintainer wrote. But basically what happened here is that the maintainer for this is this one guy in Russia that has been maintaining this by himself. He got into some legal trouble. He was involved in some sort of car accident and went to jail for a while. And this open source project that was relied on by so many people essentially went unmaintained. So this is a very extreme example, but an important one to understand and to take into consideration. And finally, we need to talk about the impact of upgrades, because as you probably noticed, upgrades is all we talk about, right? You have a fix for a vulnerability that's in the latest version. Then what do you need to upgrade to that latest version that has the fix? Or we talked about outdated dependencies. What do? You need to get up to date in regular cadences to hopefully make small upgrades over time instead of one big upgrade for something that's 75 versions behind. But what happens when you upgrade? Of course, there's always a chance that any small change in code can absolutely ruin everything, all of your the interconnected web of your application, even if you do something as small as change a letter from lowercase to uppercase. But we need to have some sort of basic understanding of who are my downstream partners, who else is relying on this package that I am about to change. There are not many tools out there in the market right now that will tell you exactly what will happen if you upgrade and what will be the blast radius, if you will. But having an understanding of your dependency graph and who is relying on which dependency at the very least can help you understand who might be impacted. So all of this is to just make the point of we tend to take in all of these open source dependencies in order to fix or accomplish something with a certain functionality. And it becomes this massive sprawl that represents a lot of our application that we have almost no visibility into. And that really comes around at us when we try to upgrade and when we try to maintain these. I hope this has been useful and informative for you. We'd love to get your feedback. Thank you, and we'll see you on the next one.